Yep. Hello everyone. Good morning. Are you able to hear me?
Yeah, hi. Good morning.
Okay. Okay. So, anybody got a chance to test our ML file or workflow pipeline?
Yeah, we tested with our use case. Yeah, and it was working fine.
Okay, it worked, right?
Yeah, so I just missed only two things like from pops up to cloud function triggering that I was pending, but rest everything is working.
Okay. Okay. So, fine. It's good. So, I want you to try out one more thing. So, which is actually workflow to PubSub a message. So we have seen the integration of BigQuery, we have seen integration of data proc, cloud function, all those things we have seen, right? So I want you guys to try out from workflow how you can push a message to the subtopic. Okay, so the problem statement is from workflow you need to push a message to the pub subtopic. That's it. Very simple. Okay. Because this will help to trigger other process. Let us take an example. Your data engineering or your complete processing got completed. And the immediate step is you need to trigger a modeling pipeline. Okay. So now the modeling pipeline is a Vertex AI job or some other uh, cloud run job or whatever it is. So you need to trigger that job. So to trigger that, after your data engineering pipeline, you need to push a message to the pub subtopic. So if you try it out also, so it will help to understand or to understand how actually the pub sub to workflow integration will happen. Okay, so that is one more thing that I want you guys to try. Okay.
Yeah,
Okay, fine. So today we are going to discuss a real-time project use case. Okay, so we will take the data sets that we have seen, right? I mean, for the PySpark use case, we have seen right? We'll take that as an example. Okay, I'll explain the complete project architecture, how the flow will be. Okay, and I want you guys to implement that project by using all the technologies that we used. Okay, so let me quickly share my screen. I'll quickly explain how that project needs to be implemented, and I'll explain the solution architecture of that project. Okay, so let me share my screen. Are you able to see my screen? Yeah. Okay. So here, if you see, I I have SQL Server as a data source. Okay. So that is my data source. Let me pull all the indicators. Okay. So this is how your project flow is. Just give me a minute. Okay. See here, you have SQL Server as a data source, and where you have a lot of tables in it. Okay, and your data ingestion tool is NiFi. So you are using in your project, your architect suggested to use NiFi as a data ingestion tool. Okay. So now your NiFi will ingest the data into Google Cloud Storage. Okay. Just 1 minute, guys. Yeah. So your NiFi will ingest the data into GCS cloud storage. Okay. And that is the raw layer. Be very, very clear. The data in the raw layer is in a Parquet format. Okay. You need to note down all these contents, guys. Okay. Your data ingestion tool is NiFi. Okay. And you have four different source tables that are there in the SQL server. Whatever the CSV files that you have, just upload them into the SQL server tables. Okay. And then you have to create a data ingestion pipelines for all these four tables. Four different pipelines will be there. Be very, very clear. Data ingestion should happen for one table. Okay. So now, sorry, you need to create one pipeline for one table in data ingestion. Okay. So you should have four NiFi pipelines for your four tables. Okay. Now, the schedule of these four NiFi pipelines are every 1 hour, every 1 hour. So every 1 hour, your pipelines should trigger and go and take the latest data and then push it into the GCS directory. Okay. So that is the first part. Okay. What is the first part? Let me just note down. So the sample data, it's your choice, guys. You can take anything. I'm just taking that use case as an example, but you can take anything. You can take medical related data. You can take retail related data. Okay. So the data, you can have n number of tables in it. Okay. End of the day, how you are processing and loading it into BigQuery is something that is important. Okay. So now let me quickly note down what we are trying to discuss, right? Project use case, analytics. Okay, that we have seen, right? Retail data analytics. And remember, this project you should not keep in your resume. Be very, very clear. This is not the project that you will keep in your resume. This is the project for you to implement. Okay, this is the project for you to implement. Okay, in resume, you need to keep projects with clients that are there in the market. Let us take an example. I'm working for a bank called Wells Fargo. So I'm working for a bank called Duce. So those are our clients, right? So we should work for them. So that is a different case. Okay. So so you need to put your client name, and then the roles and responsibilities are same. Okay, roles and responsibilities that you are going to keep are same, but the client name will be different. So this is retail data analytics. Let us take an example. I'm taking DMart is the client. Okay. So DMart. Okay. So now I have all the tables, right? So what are all the tables that I have with me? I have sales, I have products, I have stores, and what is the other CSV file? That's it. Products, sales, and then stores. So I have products table, sales table, and then stores. Okay, so this is my source. Okay, and then I'm using NiFi as data ingestion tool. Okay, now for this, what you need to do, you need to build a pipeline. Okay, you need to build a pipeline, develop data ingestion pipelines for all the tables and load data into GCS in Parquet file format. Okay, and the run schedule of all the ingestion pipelines are every 1 hour. Okay, so every 1 hour, and the GCS incremental load pattern is append. Okay, is daily append. Okay, so now what do I mean by that? So every 1 hour, your pipeline will trigger and it will go and fetch that 1 hour window data, and then it will push it to GCS into the day directory. Okay, into the day directory. So what do I mean by that? So now let us understand it. So you have a table here, okay, ID and name, salary in the source system, and now you developed a ingest pipeline. Okay, you developed a ingest pipeline, and you are placing the data into GCS. Okay, now in GCS you need to create a raw directory. For example, your bucket slash data slash raw. Okay, or else you can say data slash retail slash raw. So under this, you will be having table names. Okay, so products, guys. Okay. Okay, so here if you see, you have raw directory. Under raw directory, you have products. Okay, and you should maintain a watermark table to watermark. Okay, and this watermark table will be in SQL Server. Just maintain it in SQL Server. Okay, so create a watermark table in the SQL Server, and the schema for the watermark table is table name. Okay, and then last modified or last loaded time. Okay, table name and last loaded time. Okay, that's it. So this is your watermark SQL Server table, and your NiFi pipeline will go and take this watermark. Okay, and it will add 1 hour, or else it will minus 1 hour, and then it will create the query, right? So for all the source tables, you should include a column called last underscore modified. Remember, for all the source table, you should include a column called last underscore modified. Okay, so load all the source data into SQL Server tables. Okay. Now add last underscore modified column in all the tables. Okay. So this last modified column. So what is the logic for it? The logic for it is default current timestamp. Okay. So you know default constraints. So we have seen it. So and you need to put the current timestamp so that as and when a record got inserted into the table, automatically it will the timestamp will be updated. Okay, so it's a default default current timestamp column. Okay, so last modified column you added. Okay, now you need to develop a watermark table, or you need to build a watermark table where you need to store all your last run times of your tables. Okay, now here if you see table underscore name comma last loaded time. Okay, so this is the schema for this. So now you created this watermark table. Okay, so what your NiFi pipeline will do, your NiFi pipeline will go and read this watermark, and it will run for that watermark. Meaning, here let us take an example. You just manually created a record called products. So in your watermark table, you have to insert a manual record first. Okay, products, and the last modified time I'm giving it as 10 a.m. or else last loaded time I'm giving it as 10 a.m. Okay, so today 10 a.m. or else date 2024 09/13. Okay, so 10 a.m. Now what your NiFi pipeline will do? Your NiFi pipeline will read this timestamp. Okay, and then do a minus of it, -1. Okay, or else do the +1. Okay, so you need to create the incremental condition, right? So what I can say. Okay, so let me put this in another way. I don't want to confuse you guys. Okay, so once you added last modified time, right? So what your NiFi pipeline will do, your NiFi pipeline will go to these tables, okay, and then fetch the maximum current timestamp. Okay, fetch the maximum current timestamp. Okay, so if it is a fresh load or starting load, first load. Okay, if it is a first load, ingest all records using select star. Okay, and update the last watermark. So this is your first load. Okay, so when you are doing the first load, what your pipeline should do, your pipeline should ingest all the records and get the maximum timestamp from here, and then it will update the watermark table. Okay, so that is something that you need to do. So for this, you will add all the dummy timestamp beginning in the beginning. Okay, 2024 09 13 10 a.m. Okay, stores. Similarly, you will add it for the stores. Okay, now if you see, you have added a dummy watermark for all the tables. Okay, but once you extracted the maximum timestamp after full load, I mean this is historical load. Okay, this is the historical load. So you need to load all the data first, correct? So you loaded all the data in the first run, and then you updated the last watermark, meaning whatever the maximum current timestamp that you have, that you need to pick, and then you need to update it here. Okay, so the maximum current timestamp I have till 11. Okay, 11 a.m. Okay, you updated it. Okay, now for the next 1 hour run, for the next 1 hour, when your pipeline got triggered, so what it should do, it will go and pick the maximum timestamp again, and then that will be your end condition. Okay, and the starting condition would be this timestamp. Okay, so next incremental run should happen for 1 hour window, meaning your pipeline will trigger for every 1 hour, right? So now it will fetch the max last modified time and fetch the previous watermark time from watermark table. Okay, now form the SQL. Select star from products where last underscore modified greater than last underscore modified greater than or equals to previous watermark time. Okay, and last underscore modified underscore time last modified less than the max of last modified. Okay, so you need to treat this query and then pull the records and ingest into GCS. Okay, so your ingest path should be like this. So GS ingestion path. Okay, GS colon slash slash and then bucket slash project, okay, slash data slash retail, or else we'll say data slash raw slash products, meaning table name, slash date slash Parquet files. Okay, so your pipeline will trigger 24 times because you have 24 hours, so it will trigger, I mean, it will trigger for every 1 hour, right? So every 1 hour you will be getting new records and you will be pushing them to the same date directory. Be very, very clear. Okay, you'll be pushing them to the same directory. So every day it will be cumulatively running. Okay, every day it will be cumulatively running. So if a new day comes in, so it will create the new directory under the table name and it will place all the Parquet files. Okay, so till here, any questions? This is the ingestion part of it. Any questions, guys? Are we clear?
Yes, Venki.
Okay. So the next part is developing your processing. Okay. So develop a PySpark application, okay, to process the raw data. Now, this PySpark application, like we developed a PyCharm project using OOPS, right? So a framework-driven kind of a project, config-driven kind of a project, and then build and deploy using the wheel file. Everything you should follow. Okay. So develop a PySpark application to process the raw data. Okay. So now once you develop this PySpark application, the trigger for this is cloud scheduler. Okay. So your PySpark or your processing workflow will trigger will trigger every every day. Okay, daily once it will trigger. Okay, daily once it will trigger. So it will always run for the previous day. Be very very clear, it will always run for the previous day. Okay, so your run date equals to current day minus 1. So your processing pipeline will always trigger for the previous day, not for today. Be very, very clear. Okay, because your reporting or your machine learning is okay for the 1 day delay. Okay, so that is why I'm just keeping 1 day delay on the target layer. Okay, in the target layer, they can see yesterday's data, not today's data. Okay. So later on, you can tweak the pipeline to make it more real time. It's your skill. But for now, I'm keeping 1 day delay. Okay. Meaning your processing pipeline will trigger today and it will go and collect previous day data, or it will go and collect the previous day data from the GCS. Okay. The reason being, your NiFi pipeline ingestion got scheduled for every 1 hour, and if you trigger it for today, you don't know which R data is missing or which R data is loading, right? So that is the reason I'm just putting 1 day delay in the processing pipeline so that it will trigger for today. It will run for yesterday's data. Okay. So now, as and when your NiFi pipeline ingestion got completed, you need to maintain a table called control underscore table, load control table. We call it as load control. Okay. And in this table, what we will store? We will store all the status related information. Okay. So now load control. So under this load control, you will be having table name. Okay. Table name, ingestion time. Okay. Ingestion time. And then you will be having ingestion status. Okay. And then processing status. Okay. And then you will be having your loading status. or else you don't need it. So you just keep processing status and processing completion time. Okay, so that's it. So here in the control table, what you will maintain, you will have table name, ingestion time, and ingestion status, and then processing status, and then a processing time. Okay, you will maintain this for your audit and control purpose. Okay, so now what will happen? So your NiFi pipeline, as soon as your ingestion is completed, it will go and insert a record here, products and the ingestion time. I mean the current time stamp of your pipeline, and then your ingestion status. So what is the status of the ingestion, whether it's success or failed? Okay, so and then processing status will be null, processing completion time will be null for that table. Okay, if only the ingestion got completed, right? So it will keep processing status and processing completion time will be null. Once your processing pipeline got, or once your workflow got completed, at the end you need to update this table. If it is a success state, then you need to come back and update this load control table. Okay, so processing status and the processing time. Okay, so that we can easily check whether all the tables got loaded or not, where the tables got failed. Everything we can actually simply check from this table. Okay, that is the load control table. So now you triggered a cloud scheduler, so and cloud scheduler with pubsub or else with workflow trigger. Okay, now you will build a workflow. Okay, it is same, guys. So workflow, your cloud function. Okay, cloud function will read the data, read the current day -1 date, and to pass it to GCS, or else I can say you will pass your. Okay, so in your workflow, what you need to do, you need to have assign variable with all the table names. Okay, let us take an example. You have 4 tables in our case. So I assigned a list of 4 tables, table 1, comma table 2, comma table 3. Okay, and then iterate each table. Okay, and then for every table, your pipeline, I mean your steps should be same. So your cloud function pass previous day and table name, okay, as inputs. Extract GCS path, okay, from the cloud function. So and then you have your data proc job. Okay, pass the extracted parquet file paths to your data proc. Okay, or else we'll do one thing here. So okay, so in your cloud function, so what you need to do, so let me prepare, or let me change the requirement. Okay, so your cloud function will take table names list and run date. Okay, your run date will be current day minus 1. Okay. Once it has taken these table names and run date, so it will return list of paths. Okay. Table 1 underscore path, table 2 underscore path. So what these paths are? Table 3 underscore path. So these are all GCS paths. Okay, for that, for the previous day, what are all the GCS paths that you have? I mean GCS path you have. So you will extract everything. Okay, or you will prepare those paths and you will return it from the cloud function. Okay, once you return this paths list, what you will do? You will pass that run date. Okay, you will pass the run date and paths list to the data proc job. Okay, and then your data proc job will start reading all the 1 day parquet files, and then it will process those parquet files according to the logics that you have written, right? So we have already a use case that we have discussed, right? So where is that PySpark use case? Yeah. So here, if you see, this is the use case. So you will try to read all the 1 day related data. Initially, in the first load, you'll process for whatever it is there, but in the incremental fashion, what you need to do, you need to read 1 day related data, 1 day incremental data from all these tables, and then process this. Okay, and load the data into these tables. Okay, product performance report, regional performance report, and sales trends report. So these are the three target tables. Okay, so that you need to load. Okay, so now in your use case, what you will do, you will read all the data for that particular day and then process data and load into BigQuery stage layer. Okay, so for every table, for example, we will take product performance report is the table name, the target table name. Okay, for every table you will be having stage table. Okay, meaning the stage table will be like this: stage underscore your table name, product performance report, and you will be having a target table name which is the actual table name. Okay, and your 1 day processed data will be loaded to stage table name and to the stage table BQ stage layer with truncate and reload process, meaning every day it will overwrite the data in the stage layer. Okay, every day it will overwrite the data in the stage table. Okay, now you have you have to write a stored procedure to merge or to append, or else to append incremental data. So your target load strategy is incremental append. Okay, incremental append. So your stored proc, what it will do, it will take the data from the stage table and then it will load the data to this table. Okay, meaning it's a insert into target table, select star from stage table. Okay, so every day, as soon as your data proc job completed, your data proc job will load the day data into stage table, and once it got loaded, it will trigger the stored proc. Okay, your incremental table strategy is incremental append. So what it will do, it will try to it will try to append the data to your target table. Okay, so your target table should be partitioned on day. Be very very clear, your target table should be partitioned on day. Okay, and every your target table should be having a column called ins ts system insert timestamp. You should maintain this column in all the target tables. The reason being, this column will tell you when the record has came into the system after processing. Okay, so it's a current timestamp actually. It's a current timestamp. When you are loading the data from the stored proc, you need to have this column in the target table, which is actually the current timestamp. Okay, so here, this is the logic from stage to target. It's a simple incremental append. Later on, you try for incremental merge. Okay, incremental merge, SCD type 1, and then you do SCD 2. So that's how you can try different ways. Okay, first we are starting with the incremental append, then you keep on trying for multiple solutions, like SCD1 you implement, SCD2 you implement, right? So we have discussed all those things, right? So this is the target load logic. So once your BigQuery load got completed, then you need to call another cloud function. Okay, this cloud function will update load control table. Okay, clear guys. So here one cloud function will return all the GCS paths for that particular day, and then you will pass the dates and paths to the Dataproc job, and then process data, load it into the stage table, and then execute the stored proc, which will do the incremental append to the target table. Okay, and your target table should be created with the partitioning on day. Okay, and the day meaning, you have system insert timestamp, so you can take this column, and day of this column you can use the partition key. Okay, and then your cloud function, once the target load is successful, or once your stored proc results or status is successful, then you need to execute, based on the status, you need to execute the cloud function. Whether it's a success, you need to update the success in the control table. If it is a failure, you need to update the failure in the control table. Okay, with status. So this is the complete requirements document. I want you to create the workflow for it, and you need to schedule it every day. So daily once you need to schedule, and that too you need to schedule every day. Run schedule every day at 1 a.m. Okay, every day at 1 a.m. So it will trigger at 1 a.m. and it will go back to the previous day. All the Parquet files will be available, right? So that is why. So every let us take an example. You can trigger every daily 6 a.m. in the morning. Okay, that's it. So 6 a.m. in the morning it should trigger, and then it will go back to the previous day. By that time, by today 6 a.m., all the previous day files will be generated, right, in the GCS. So there won't be any conflict between the ingestion and processing. So you can pretty well extract all the paths and then trigger the processing logic, and then uh, uh, load the target data. So once you have the pipeline ready, I want you to add data to the source system. Okay, manually update the records, or manually load the new data to the source tables, and then observe your pipeline whether it is incrementally picking or not. Okay, and debug your pipeline if you have any issues, right? So this is the complete project report that you need to follow, and you need to implement this project in your GCP. Okay, so And I will be putting a sample resume also in the Git repository. I'm preparing it. So in the Git repository, I'll put the sample resume and I'll upload the sheet also. Try to prepare your project. So anybody have any questions in this project implementation? And there is something that I missed to tell you, which is actually the cloud scheduler part. So here, if you see, it is very simple one. You need to give the schedule, run schedule. That's it. So here, if you see the cloud scheduler, if you go to here, yeah, see, I'm just enabling the cloud scheduler API. So once you enable, so you just need to give the schedule daily at what time your pipeline should trigger. That's it. For that reason only we'll use this cloud scheduler. Okay. So schedule a job. See here. So here, if you see your job name, you can define this must be unique across all the jobs in the same region. Define the schedule name, your job name. Let us take an example. Job underscore retail underscore processing. Okay. And then region, a description you can say here, this is the frequency. See here, the frequency meaning the interval. So at what time? See here, Monday, every Monday. So this is the cron schedule. Okay. In Linux, I want you to every 3 hours. If you want to schedule for every 3 hours, then this is the cron schedule that you need to give. Okay, it's very simple. So like that, you need to have a cron schedule for every day. Okay, so you need to have the cron schedule for every day. Then place that cron schedule here, and the time zone. Which time zone? Asia Pacific, right? So where is this? Yeah, you try to select our time zone, so there will be, or else.
Check bottom.
But I don't know. It has given all UTC. Korean which, yeah, Indian Ocean Time, Indian Standard Time. Okay, so Indian Standard Time, Kolkata. Okay, so this is your time zone. Okay, then here configure execution. See here, trigger type. So you can select workflow simply. Okay, so it will directly trigger your workflow. That's it. You once you create your workflow, you just give your workflow name. See here, my workflow has appeared. Okay, so just give your workflow name and the service account. Use the compute engine default service account, and then the arguments. If you have any arguments that needs to be passed, just pass it. That's it. Okay, and continue. Okay, and then create. That's it. There is nothing in this scheduler, guys. You just give it for run schedule. Okay, so once every day automatically your cloud scheduler will trigger uh, the the workflow pipeline. You don't need to manually run the workflow pipeline. So it is the automated scheduler in that time zone. If that time interval got came, it will automatically trigger the workflow. That means you need to identify the cron schedule. That is the only thing that you need to learn here. So you can see the cron tab. So this cron tab meaning uh, you have very good documentation here, right? So here first star meaning minute, hour, day of the month and day of the week. See the stars meaning. So if you want to schedule it every day, then identify what is the schedule or what is the cron information that you need to pass. Okay, so this is something that you need to look at every day. See here, every day 12 a.m. Okay, so like that you need to identify every day 6 a.m. how to prepare your cron schedule, right? So once you have that cron schedule, just place it here, and then enable the workflow trigger and create your schedule job. That's it. It will automatically trigger your pipeline. Guys, anybody have any questions here?
No.
Okay. So that's all I have, guys. So I will be uploading this project requirements document, and I will be uploading the sample resume also in the Git repository. So I want you to start implementing this project, and I want you to prepare your resumes, upload it to Naukri as a GCP data engineer, and start exploring the jobs. So that's the end of our sessions, guys. So this is the final session that I want to discuss. So and thank you so much for all your patience, and thank you so much for your time for attending these sessions. Hope these sessions has given you at least a good understanding on Google Cloud Platform, and the payment related things. So people who did not completed the payment, please complete by today end of the day. So we have reached our course end. So once you completed this mini project, once you prepared your resumes, you can reach out to me in the groups, in the group, with your resumes preparation. Okay, and let me know if you need any help in resume preparation. I'll support you in WhatsApp. Okay, so and I want you guys to definitely complete this mini project. Okay, so once the mini project got completed, then you can pretty well prepare the resumes by looking at my sample resume. You can start preparing the resume and upload it into the Naukri or LinkedIn, wherever it is.